Hey everybody, we're back from my home office in Newberg, Oregon, and we're going to be going through CodeHS, Turtle Graphics. We're picking up where we left off from last time, and so I'm just gonna go ahead and go to that screen. Hold on a second. And we're gonna be doing intro to programming with Turtle Graphics. Better share my screen here. And when we last left our heroes, we were doing for loops. So we did 2.1 through 2.4. As you can see, I don't do all of the exercises. I'm doing a certain subset of each one. What we're going to do is we're going to pick up at turning Tracy, and we're going to get through functions and maybe to artistic effects. Not entirely sure. If possible, I would love to cover top-down design. It's its own sort of topic, and I've covered it in class before, but it doesn't hurt to review because it's a wonderful way to solve problems. All right, so without further ado, we're going to go to the turning Tracy using angles. We're going to take a look at the quiz to see what is on it. So we have commands like right and in parentheses an angle, a number. And then we have a set position command. And we have things like if you want Tracy to complete her command immediately. So speed. So we're going to look at a couple things like turning, setting a position, speed. If you want 3 circles to be drawn next to each other after drawing the first circle, how far would you need to move Tracy before drawing the next circle? All right. There's some options there. So these are the kinds of concepts that are covered in this unit. So we're going to jump to the first exercise in here, and it's a hexagon. Okay. I love hexagon, and maybe that comes from the fact that I like to play Catan. Settlers of Catan, it's a wonderful game, and you have these pieces that form an island made of hexagons. They're great for tessellations because they just line up next to each other really well. So we're going to write a program that will have Tracy draw a hexagon. And so a hexagon is a 6-sided regular polygon. And what makes it regular is all the sides are the same length. And the angles between, they all form angles, each line, they are identical. And one of the cool things about regular polygons for you to understand, which you probably already know, but I'm going to refresh because it's good to think about, say, for example, a shape to decide how we're going to solve a certain problem. So if we want Tracy to draw a hexagon, the angles of each turn are going to add up to 360 degrees. And one of the cool things is we could get angles using simple math. And so there's a lot of ways that we can solve this that take advantage of just some very simple mathematical concepts of a regular polygon. All right, the idea you're going to go forward. As you can see, we're going to have to turn left each time. And did we do variables yet? I don't know if we have or not. I love to use variables. I think we're going to do that in the naming conventions. Let's just hit the docs if they let us do variables. Yep, let's do it. Let's see. In the docs, we're talking about speed, right? So these were some of the commands. So there's movement, drawing circles, pen. We've gone over that. Rotation. Here we go. So we can turn left. We can turn right. We can give an angle. And of course, 90 degrees is a 90-degree turn, which is basically kind of like going around the corner of a square. 180 degrees means a complete turnaround. And then 360 degrees, not complete turnaround, but like if you're facing right and you go left 180, you're going to be facing the left. If you're facing north and you do left 180, you're going to face south. And honestly, the difference between left 180 and right 180 is just the way you see it turning. But the end position will be the same if it's 180. So hopefully you're familiar enough with degrees and turning that this is all intuitive to you. One of the things you can note is you can give negative values. Not only that, but you can give values beyond 360. And in essence, it will go 360 plus how many more. So if you were to do double, you're going to go 720. It would be the same as 2 360s. It's almost this, you might as well just say you're not even going to turn it off unless you want to see it spin because that's fun for you. All right, so that's angles we're going to go over. Set position is cool. You just give an X and Y location. But you can also set the X and you can set the Y, which is cool because then Tracy will just move exactly to that position. One thing you got to know is that if you set the X and this is going to be like a 100, that's going to be a specific location on the screen. All right. So it's not like you're just adding to the X, you're actually going to location. Now, this is similar. I've done things in game design with Scratch. And with Turtle graphics, 0, 0 is the center. So it's like your Cartesian grid. So for some of you that have been doing a lot of plotting of functions and things like that, you probably appreciate this. If you're in my game design class or you're doing the JavaScript graphics, you'll note that 0, 0 is actually the upper left-hand corner. So it's always a good idea if you're going to do anything drawing related to find out what is the coordinate system, because that's going to affect a lot of different things. So it's good for you to know. If we were to say set X 200, we'd basically jump all the way to the right-hand side. If we were to say set X 100, it would be right where that little hash mark is. If we're going to set X to negative 100, it's going to be there. So you get the general idea. So it's basically 400 pixels tall by 400 pixels wide, and 0, 0 is the center. By setting a position, that's an instantaneous move. So I don't think they were referring to speed. But you could do the fastest, speed 0. It has the same impression that's like no animation. It'll go so fast, it'll just instantly do whatever you want it to do. Okay, so now that we've covered all that, let's do the hexagon. Let's get going. Like I said, we're going to take advantage of variables. And in Python, variables are really easy. You just come up with the variable name. Let's say turn angle. Oh, by the way, we're going to use what's called snake case. Snake case is where when you create a variable or a function name or an object or a file name or whatever, a lot of times Python developers use what's called snake case, where you combine two words, for example, turn angle. The way you combine them is by putting an underscore. And it looks kind of like, it's like a snake on the ground. So they call it snake case, which is kind of fun because it is Python after all. All right, so turn angle. We know it's a hexagon. We know we're going to do 6 sides. In fact, if we want to, we could just put sides equals 6. And then we could do turn angle equals 360 divided by sides. Okay, and then we could do a for loop. And we're gonna do a for loop for every side, right? So we're gonna do a for, and as you may recall from the last video, we can do I in range 6. Okay, we can do a forward. How long were the sides? 6 points. Show exercise. 50 pixels. Okay, cool. So forward 50. Sorry, I got to click in here. Forward 50, like so. And we're going to go left because we're turning left. Oh, by the way, if you don't have your left and right, get that down, especially if you haven't got your driver's license yet. When you start driving, you better get your left and right figured out quickly. If someone says turn right, you don't want to get that one wrong when you're going 45 miles an hour down a street. Well, you wouldn't turn at 45, but you get the idea. So we're going to turn left at turn angle. Why not? Oh, we could do for I in range sides. You like that? I do. All right, that's it. That should work. Because you know why I knew it would work? I was confident. Well, one, I was confident that I knew how to do a for loop because I've done them so many times. But the other thing is I just know my math, right? I know how hexagons work. I know regular polygons. I know, I mean, this is really handy. If you want to do an octagon, check it out. This is the best. 8. The value of variables are just wonderful. You want to make a triangle? Sides 3. No matter what you do, you can't get it wrong. Nonagon. I love Nonagon. Ever since They Might Be Giants did a song about nonagons. And here we go. There's our 9-sided regular polygon. Is that awesome or what? It is. Just nod. All right, but this was going to be a hexagon, and so there you go. But you see the value of using variables. Because I used variables, all I had to do to change this drawing was change this number right here. This is going to be really handy when we get to functions later on. All right, because we could draw a function that could draw any regular polygon with that code right there. So wherever possible, use angles. So that's going to be my first phrase that pays. Okay, whenever possible, use variables to. You can use it for a lot of things. Simplify, break down a problem, make it more readable. And you don't have to like do all this. If you're watching live, you're good. You're watching live. I trust that you're paying attention. So variables could do so many things, right? It simplifies your programming, right? It helps you break down a problem and make your code more readable, right? I mean, you saw that. I could make any regular polygon now by changing one number in one line of code because I used variables. All right, incredibly powerful. All right, so variables, and notice it's more meaningful because we know its sides, right? And we got turn angle. So this makes it a little bit more readable. If I just put numbers in there, a lot of people might wonder, if I were to do the math myself and write down that answer, what's 360 divided by 6, I would know that's 60, right? So I know the turn angle is 60. But then if all I just did was get rid of that, and then I put here 60, and I put here 6, it might be shorter, 3 lines of code, but it wouldn't be as understandable. Let's see if I was right about that. I was. Okay. Good. My math is still good. I still got it after all these years. All right. And then we'll just change that back to 6. Submit and continue. All right. Hopefully that was very helpful for you. If you haven't solved that one, there you go. There's your solution. Pretty awesome, right? All right. X marks the spot. Okay. We could do the same sort of thing. All right. So I'm going to give you the algorithm for this one. I'm not going to solve it, though. Okay. Okay. So we're going to loop 4 times. All right. Now, if I were to call it sides, that wouldn't make a lot of sense. We could call these segments. They're segments of the letter X. So you could do this. You could put, so I'm going to do this as an algorithm, okay? Set segments to 4, okay? That's what you're going to do, okay? And then you are, now normally your turtle is facing the right, and it's going to need to turn left a little bit. This is where it gets a little bit trickier because the X is not, you're not going to go straight out. You're not going to go straight up. You're going to go right in between those two. So you're going to want to turn left just to get in that position. And I'm not going to solve that for you. It's going to be halfway. I'll just put half of a right angle. And as you may recall, we defined a right angle. Half of a right angle. I know it's halfway between because we're going to be facing the right. We're not going to go all the way up here. A right angle would be facing straight up. You want to be exactly halfway between. Okay, so you're going to need to do that. That's going to basically to get yourself into position. Okay, once you do that, we're going to do a repeat 4 times. Okay, what are we going to repeat? Well, I'm going to tab over. We're going to go forward. I'll just put move forward. And did it say how far we're going? X with a total diagonal distance of 200 pixels. Total diagonal distance. What does that mean? Like, oh, I guess we're going to divide 200, so each segment, it's going to be 1/4 of that. So, all right, fine. 1/4, we'll just put 200 divided by 4. I'll let you either do the math. Ah, There we go. Set length, or you could even say segment length, to 200 divided by 4. Or 200 divided by segments, right? All right, so I'll let you decide how you want to do that. All right, anytime you see a number sort of repeating itself, guess what? Everywhere you see that number, you could give the variable instead. All right. Okay. So we're going to move forward. And we're just going to move backward, right? Or you could put set position to the center. And then you're going to turn left. Well, we could have a turn angle. Because guess what? It's going to be the same way we did it. When we are done, we should be back at 360. So we're going to want to turn. Basically, it's right angles. So you could just put to a right angle. I'll let you figure out what that is. Or you could do 360 divided by segments. Either one of those are going to work. Okay. Okay, so if we move forward, we set position to center, and we turn left, we're going to be facing that way, ready to go forward again. And so if we repeat that 4 times, when we are done, we'll be right back here. So that would be 1 turn. That's a 1 time. 1 turn, 1 turn, 1 turn. So that should do it 4 times. 1, 2, 3, 4. And okay, so we may want to turn left 1 more time at the end. Or we could, if we turn, then draw. Yeah, let's see. Let's like think this through. So if we were to start facing here, but we turned first, then drew, then moved forward, and then set our position, that would be 1. And, okay, so let's do it that way. I think if we do it this way, we don't have to do another turn at the end. Oops. Now I don't have a little drawing thing, but it's the idea of we haven't drawn this line. We turn, draw, set position. That's 1. Turn, draw, set position. 2. Turn, draw, set position. 3. Turn, draw, set position. 4. Yeah, that would work. If you need to do pen up and pen down, you can do that, but that is our algorithm. So let me just do this. That's it. That's our algorithm for doing this. Okay, so this is what I recommend you do if you're going to solve this. I would, if you haven't done it yet, I would pause this video and look this over and code it out. All right. So for those that are watching, you can do that. I'm going to comment this out, and I'm going to leave the comment there. And let's see. I'm trying to think if I want to have a phrase that pays related to what we did here. Okay, I could say if in our repeat we turn left first, we save ourselves 1 final turn at the end. We can save ourselves a line of code by turning before we move. You said I was going to have to turn at the end if I had moved then turned and set position, I believe. Actually, you could maybe prove me wrong by coding it. I haven't coded it, so maybe I'm wrong. But in our repeat, try turning left first. So that'll be our second one. We'll put this in X marks the spot. In the repeat loop, turn first. There we go. So that's going to be your phrase. So, and then of course, if you want to, you can prove to me. All right. So you can prove to me you don't have to turn first. You can just say, look, in X marks the dot spot, you don't have to do an extra turn at the end. You can go forward and then turn. I have proof or whatever. And that's fine. I was thinking this all through and I thought that was right, but maybe I'm wrong. So prove to me I'm wrong, either by code or explanation. Code's going to be easier. All right, so I am going to save this, but I'm not going to turn it in, and I'm going to move to the next topic. Let me do a quick check on my time. And well, in the meantime, I'm going to get my, I'm going to check without having to see all that. Let's do this. We're going to jump to comments, and I just want to let you know comments are really, really helpful. This is called a it's like a what's it called? It's a triple string comment. So this is how Python covers multi-line comments. They also might call this like a doc string. You might hear people call it, because in a function or a class, sometimes functions have these right after in their definition. But this is like a multi-line comment, and a lot of times programmers will use that. Other times they'll just do the what I just showed. By the way, that was a control / to comment things out. So you'll see a lot of Python developers just use the hashtag comments. But technically, this would be a multi-line comment, and a single hashtag is for a single line comment. People sometimes put comments to the right of an instruction. I prefer not to. I think it makes it more cluttered and ugly. Comments are ignored by Python. They're there for you and I. Okay. And so if you look here, comments tell you what you're doing and why. You don't want to go overboard. You don't want to have too many comments. This is drawn just sparingly enough so we have a good idea of what we're doing. If you looked in the last one, that whole algorithm was considered a comment, or they're all commented out, right? So in a way, this kind of stuff you wouldn't have to do a comment on. If you just put segments equals 4, you wouldn't really need that. So I would use that, but this is something you could use while you're going through. If you've taken the CS Academy course, you'll note they do a lot with comments to help guide you as to what you're supposed to do. So comments can be really, really handy. All right. So the idea behind comments is just make sure you're doing it in a way. Think about like, what's the big picture of what you're doing? Okay. So it may not be readily apparent that this is drawing two circles next to each other, but it is. And I want to just a little hint on some of there's one that we didn't even go into, a pyramid of circles. If you're having trouble in the pyramid of circles, right here, that's going to help you out a little bit. So when you draw a circle, this number is the radius, right? And so you're drawing it, and you're right here, let's say. You need to start, by the way, when you draw a circle, you start at the bottom of the circle. So wherever your turtle is, that's the bottom center of your circle when you do circle, like that. So if you're here, it's going to draw a circle with a radius of 50. And you need to go twice the radius, which is the same as the diameter of a circle, before you draw another one. But if you do that, your two circles will be next to each other, like you see here. So this draw two circles next to each other is what we're doing here. Now that's not necessarily readily apparent when you look at this code. So the comment here is a really good guide. All right. Now notice here, we have a comment here explaining what's going on. And so that's really good, because you might wonder, why are we doing this pen up, set position? What's the point of this? Well, that's to get us down here where we need to be in order to draw this. And then we're going to move to the top of circle row at position -50, 0. So that puts us up here on this. And then we're going to draw two more just like we did up here. And when we get to functions, which we are going to get to functions, I just want to remind you, we are repeating the exact same code here as we're doing here. So if we just defined this as one function called draw two circles, when we get to where we want to draw two circles, we just call that function, and we're going to get to that. But comments, this is really well orchestrated set of comments. They just are giving us the big picture. You should have like one comment for every big chunk of code. If you think about it, if you break down this problem, this is what we're doing. We're going to the bottom left circle at a particular position. We're going to draw two circles next to each other. We're going to move up to here, and we're going to draw two circles next to each other. These comments are all just telling us what the program's going to do. And then the code does what it says it's going to do. And here we go. There you have it. Okay, so set position, by the way, is really handy, right? Because when we were done with this loop, we were actually forward over here, so we had to then jump over here. We didn't have to think in terms of how far do we have to go, what angle are we going to turn. We just get ourselves to where we need to be. All right, so that'll be my next phrase that pays, okay? Use your comments to give the big picture. Okay, use your comments to give the big picture. So you think about what are the big steps to your program. So it's kind of a problem solving. You're breaking it down into chunks. So like, okay, we're going to draw 4 circles. We're going to draw 2 circles. One row, we're going to draw 2 circles above them. So we're going to have to go to a certain position. Then we're going to have to draw 2 circles. We're going to have to go to the other one. We're going to have to draw 2 circles. So it's like those are it. It's the big things your programs are doing, the big steps. You're breaking it down. And then add a comment. So you add a comment before each big step your code will do. So I'm going to try to model that. And I do try to sometimes model it. Sometimes I don't put my comments in. My recommendation is you do your comments first. And once you do your comments, then you code it. Okay, and there's other ways. When we get to top down, we're going to go over that. Top down is another way. And we're kind of preparing you for the top down at this point. So we're at 10:24. And I've got about no more than 10 minutes. So we're going to have to I'm going to give myself a 7-minute timer. And although I kind of started late, but yeah, we're going to do a 7-minute timer. And I'm going to hear when that thing goes off, I hope. I'm going to do this. And hopefully there'll be a big sound at the end. Someone else wants to time me. I like the ones that have an explosion at the end. All right. Let's code. All right, let's move on. Naming guidelines. Oh, they're just going to give us, oh, see, that's going to prep us. Okay, hey, look, snake case, my underscore function. All right, let's go over naming guidelines. Okay, so this is how we name variables, how we name functions. Okay, you cannot have spaces. So draw a circle is bad, that has spaces. You cannot begin with a number, so that is bad. Now, beyond that, as long as you're using characters, either of these works. Oh, wait, it says follow all naming rules. Okay, there's one last naming rule that is not covered that I didn't mention, I forgot to mention. So we've narrowed it down to my function or make square. What makes more sense to you? My function? Do you know what my function does? Do you know what make square does? Let me take a wild guess here. Make square is going to, drum roll please, make a square. That's right. We know what make square is because it's obvious. This describes itself. My function is not. I have no idea what my function is. It's just a function. And this is a great time to go into my little story of Bob the chicken. Bob the chicken was a variable one of my students from a long time ago, the days of yore, made for her program. She had a program, it didn't work. She asked for help. How do I fix this? And I said, I'm not sure. And I looked and I saw this variable called Bob the chicken. I kid you not, Bob the chicken. And I asked her, what does Bob the chicken do? And she looked at me puzzled, like, I don't know. So had she named it something like make square, I think it would have been a lot more obvious as to what that variable did. It would have made it a lot easier for me to help her. And maybe she wouldn't have even had a problem in the first place. So for my phrase that pays, number 4, you, with variables and functions, make sure they make sense on their own. Okay, example, make square makes a square, right? Now, you don't want to make them too long, but I would err on the side of a longer variable that makes more sense than a short variable like MS, right? You're going to forget what MS stands for at some point. And adding a comment when you create it is probably not the best way around it. Make square, even though it's longer, is way more readable. So aim for readability. Okay, that's my number 4. And I gave you the answer here, but we're going to move on to functions. And I'm going to go right to beaded bracelet. Let's see if I've already coded this. If I have, bummer. Good, I have not. All right, we're going to break this down and we're going to do a thing. So what do we need to do? Okay, this is going to be interesting. I think, let's just see what they say on this exercise. And let's do the full. Okay, Tracy wants a beaded bracelet for her birthday. We're going to write a program that will draw one for her. The bracelet should follow these specifications. 36 beads. Okay, keep that in mind. Let's go ahead and create a variable for that. Let's do this. We'll do the triple string. Okay, so program will draw a beaded bracelet. Tracy will draw a beaded bracelet for her birthday. I didn't have to add that if I didn't want to. There must be 36 beads right there. I'm even gonna like put a little dot here. I'm gonna copy and paste. Okay, so this is good because this is my roadmap. Okay, so we're gonna declare our variables. And then we're gonna declare our function. Now in Python, you always want to declare variables and functions at the top. That is standard practice. In JavaScript, a lot of times the functions go at the bottom. So it's honestly, I think JavaScript. I don't know if that's. I'm not as much of a JavaScript developer. I'll be honest. But I remember reading somewhere that's what they do. But I know in Python, you have to declare a variable before you can use it, and you have to declare a function before you can use it. And since we're going from top to bottom, there we go. So we're going to need a function and a loop in our code. We're going to need to turn Tracy 10 degrees up after drawing each bead. Okay, cool. So we're going to do the turn angle as well. And then we'll do kind of like we did before. We're going to repeat 36 times. Radius of 10 pixels. Bracelet has a diameter of 200. You're going to need a function and a loop. You're going to need to turn Tracy 10 degrees after drawing each bead. Interesting. So we turn 10 degrees. The radius is 10 pixels. bracelet must have a diameter of 200. Oh, okay. So what I'm thinking, and it says you should return to the middle of the bracelet. Yeah. Okay. 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 Great. Yeah, that makes the most sense to me. If you start in the center, you go out, you draw your circle, and then you go back, then you're set to just. Sorry, my timer went off. So once you're back here, you're set to do your turn. Oh, heck. It was like a fire alarm. Yeah, I wasn't going to miss that video. All right, that's my 7 minutes. Now I got 3 minutes to crank this sucker out. If you want to stay with me, great. I recommend you do so because we haven't even solved it. Okay, so we're going to do a repeat, and I think our function should be draw bead. Why not? So actually, I'm jumping the gun here. All right, so let's declare our variables. Diameter. I'm going to do, no, radius equals 10. Beads. And we could put num beads, number of beads. I'm sort of splitting the difference between a longer variable and a meaningful one. NUM is used a lot of times, so I feel like I'm okay doing that. And then the bracelet must have a diameter of 200, which means it has a radius of 100. So we'll call it bracelet radius equals 100. Why not? Everywhere we can use a variable, let's use it, and we don't have to worry about other things. So we're going to do a bit of a top-down approach, which is a kind of a talk about what we're going to be doing in the next time I come back to this. I'm going to do a for I in range number of beads. Oops. And then we're going to draw bracelet. Okay, so this is the function that we're going to run, but we haven't declared it. So now we have to declare it. This is very common among programmers, is that they will create they'll call the function, then define it. It's just a way of thinking about what it's going to do first before coming up with all the details. In draw bracelet, because it's a function, I'm going to probably want some information inside of there. So we may want to pass it these variables here. Now they're kind of constants, and I can't remember if Python will be able to. I think inside a function it can read these variables, it just can't change them. So I'm gonna assume that, and then we'll find out if I'm right. Okay, so we got to go forward, and that's going to be bracelet radius. And then we're going to draw, we're going to do the circle. I don't remember, is it just circle? Commands? Yeah, it's a circle, okay. I'm having trouble remembering some of this stuff because in my, in CS Academy, we're doing circles and things, and so it can be confusing. What do we got? Do we have the radius of the bead? Yep, radius of 10. And then it said we're going to have to, okay, so we're not, after we do that circle, we can just do a set position to the center. Is that what it is, set position with an underscore? See, I can't remember half of this stuff. Oh, no, no snake case. And we'll put 0, 0. So that gets us back, and then we're going to turn left by radius amount, right? Pretty sure that's what it said in the assignment. 10 degrees. All right, well, we already know that. All right, let's run it. Oh, okay. We got to do the pen up, pen down. Pen up, pen down. Pen up. Or, yeah. All right, this is slow. Let's set our speed. And now let's run it for time's sake. Oh, that's awesome. Check it. Got it. There we go. All right. By reading carefully, using variables whenever possible, technically that's not a variable. That's set speed. And now you can see those are my comments, using a multi-line comment for the big picture, this information. And what's really handy is having this at the top gives us a good idea. Had I just thought about, I could have just looked at that without having to keep going back to the assignment, and I could have figured it all out. So that's one reason, one advantage to having this, having a roadmap to help set it up. Okay, so let's see if I have any phrase that pays. Number 4, do I have it? Let's just do 4. We're good. All right, thank you so much for watching. I'm gonna be done here, but let's submit and continue so I know I did it right. You got the answer. You've got an algorithm for the previous one. Hopefully this has been beneficial to you. We're going to go into the whole top-down approach, artistic effects. So we're going to start looking at some of these the next time we meet. And then from here on out, I'm going to try to make sure I'm modeling that top-down design. All right, well, thank you so much for watching, and stay tuned for more.